IoT, powering the digital economy. Brought to you by Schneider Electric.
Farming is the hand that feeds us, but as an industry, agriculture is something we often take for granted. The land is plowed, the crops are grown, and the livestock raised. But pressures on farmers to feed our booming population are increasing. By 2050, it's estimated there'll be over 9.5 billion of us, and that's a lot of mouths to feed. Farming has long been considered a risky investment with tight profit margins and often unpredictable yields. But it's a sector with enormous potential. According to the World Bank Group, it accounts for about a third of global GDP. And by 2050, it's thought that productivity in agriculture will need to rise by 70% just to keep up with demand. In their efforts to meet rising demand, food producers are now turning to digital innovations to increase their yield and farming efficiency. Agricultural technology, or agritech, is thriving and attracting investment like never before. Digitization along the entire value chain is seeing tech companies forge new relationships with agricultural business, with even digital heavyweights like Google and Amazon starting to dig in. So how is farming changing in the face of the digital revolution? And what business opportunities and challenges lie ahead? In this program, I'll be looking at the companies that are tackling the problems of 21st century farming head-on with the use of new digital tools and innovations. I'll be finding out how one of our oldest industries is overcoming its newest challenges and asking experts in agricultural technology about the obstacles we face on the road to the farms of the future. It's hard to talk about the agriculture business without mentioning Monsanto, the notorious farming giant and the world's biggest supplier of seeds, with around a quarter of global sales. However, as the use of agritech grows, traditional farming companies like Monsanto are vying for a share in the market. In 2013, Monsanto acquired the Climate Corporation, a company specializing in digital farming. The cost of the takeover? Close to $1 billion. I've come to the head offices of Climate Corp in San Francisco to find out why the company is proving such a frontrunner in the race to digitize farming. Mike Stern is CEO of Climate and Vice President of America's Row Crops at Monsanto. Hey, hi.
It's a pleasure to meet you.
Nice to meet you.
Welcome to the Climate Corporation.
Thank you.
Let's go to the office.
He's also the man behind more than 50 scientific publications and U.S. patents related to agriculture technology. One of Climate's key products is FieldView, an online platform that gathers and analyzes data to predict weather and field health, providing farmers with a wide range of digital tools to help maximize their yields.
Here are all my fields. They're all organized. It's a digital notebook, and it's telling us about, okay, how much rain fell on my farm in the last 24 hours, season to date, and how does that compare to the 10-year average?
Okay.
And then if they want to dig into more detail on a field-by-field basis, they can go specifically to a field.
Oh, this looks like a satellite map of the field.
This is actually a yield map. This is called split view, and they can begin to see that,
it matches.
that this is a soil map that actually is helping understand what this variability is. Red are areas of the field that are not doing too well, and green are areas of the field where the yields were much higher. And so within the app now, for the first time, a grower can begin to understand, well, what might be causing this variability? FieldView is a digital ag platform that really provides three benefits to growers. One, it helps them digitize their fields and allows them to organize their data around their fields and begin to do analytics and cause and effect analysis. It's a conduit for us to be able to give recommendations based on our investment in data science to help growers make more informed decisions about how to manage their crops. And it's also a conduit for growers to go and connect with other innovators on our platform that allows them to access other digital ag tools to bring innovation to their farm.
What about any B2B collaborations and benefits to other businesses? Are other companies getting on board with the system, and are there any examples you can share?
Absolutely. We have established FieldView as a platform, and so we've opened up our infrastructure to allow other companies to develop technology and bring technology to growers through FieldView. And we have about 30 partners right now. So let me give you an example. One of our first platform partners is a company called Veris. And Veris makes very sophisticated soil sampling equipment that gets taken across the field, and it does a meter by meter assessment of some critical soil components. Now, by itself, that's important for a grower, but what a grower really wants is to have that soil layer in the context of everything else that they're doing on their field. So now we have a soil layer that's in context of, hey, this is the corn hybrid that I might have planted, this is the density I planted, this is the weather on the field, this is how nutrients have been applied to that field. It's a very symbiotic relationship.
And with population growing so rapidly and the world's agriculture needs growing, how does this help? How is efficiency important?
Well, if you project out into the future, in 2050, there's going to be 10 billion folks on the planet. So another 3 billion than from where we are today. And we're going to have to figure out how to produce more food on less land with fewer natural resources with a changing climate. And that's a challenge. And we're going to need all sorts of technology. It's not going to be one technology that's going to help us solve these problems. We've seen these types of step changes in technology before, whether it was the mechanization of the farm in the late 1800s, or the Green Revolution, where breeding and understanding about fertility helped improve yields in wheat. And I think digital agriculture is going to be this next wave of innovation that we'll be able to apply to these problems.
Helping farmers adapt to the changing climate will surely have a positive impact on global productivity. However, another major problem facing today's farmer is the shortage of seasonal labor. Many farms are losing money because they simply can't find the workers to pick their produce. The Oxnard Plain in Southern California is famous for strawberry production. About a third of the state's strawberries are grown and picked here. The harvesting of soft fruits has always been a delicate, time-consuming operation. Traditionally, farmers have relied on hand-picking by migrant workers, but times are changing. And as worker numbers fall, fruit growers in particular are searching for new methods to gather their precious crops. Say hello to the Agrobot, one of the world's first strawberry picking robots designed from the ground up to gather this especially fragile fruit. It uses a sophisticated set of sensors to scan and delicately harvest the strawberries, and it's the brainchild of Agrobot's founder and CEO, Juan Bravo. Juan was previously head of production at Spanish engineering and construction company Hoca, but has been refining and developing the Agrobot since 2010. So Juan, you've developed this Agrobot to pick strawberries. Tell us a little bit about how it works and what it does.
We have 24 robotic arms. Each one is fully independent from the other. And each one have a camera, business system that is scanning for ripe strawberries. And when we find a ripe strawberry, we grab by the stem and we leave in a container. If we compare the picking side of the harvester, we need about 1.2 human harvesters for cleaning 1 acre. With one harvester, we can harvest about 20 acres in 3 days.
So how is the machine controlled? Do you ride on it, or is it just a screen to push buttons on?
So everything is fully autonomous. We just press the start button. The harvester, all the robotic arm starts. The self-guiding system will guide the harvester. And when the harvester reaches the end of the rows, it will stop by itself and will send the information to the human. We can control with a screen on the harvester. We can control with our phone or with a remote controller.
So what kind of interest have you seen in the product? Who's investing?
Well, right now the main investors are growing companies. They need a solution because in the next following years, the shortage of labor for this kind of jobs is gonna get harder and harder. Even the people that currently is harvesting the strawberries are getting older. So they they are investing in this kind of technology because they need a solution to keep growing strawberries.
The main business investor in the agrobot is the international berry growing company Driscoll's. Hey, John.
Hi, Luna. So nice to meet you.
Nice to meet you. I asked John Erb, their VP of Social and Environmental Impact, about the benefits of agritech investment and what kind of problems it can solve.
What it solves is really trying to take some of the kind of non-value added type movements that are difficult and things that people really don't want to do, and automating those aspects. We really want to try to create the type of opportunities for the workforce to focus on the things that require higher intelligence and things that aren't necessarily just repetitive in nature, and that really kind of wear people out and that type of thing.
And what do you say to farmers or people who might be concerned that technology and robots are taking jobs away?
Well, really it's creating job opportunities. One of the biggest challenges that we have is that there's really not youth coming into the farming industry. And so with the technological advancements, there's a lot of opportunities that really are attractive to the youth and can also kind of tap just the acumen that the kids have today. They grow up with the technology, et cetera. And so it's exciting to create those type of opportunities.
How important is increasing the use of digital technology to Driscoll's and to the agriculture industry?
Well, increasing the use of digital technology is super important, and not just in terms of automating the harvest, but there's other applications as well. For example, using visual technology to assess how much of the crop is coming in, as well as what's the state of the crop. And so you can detect where there's hot spots in the field, where there may be some insect pressure, or the plants aren't as vigorous, and those types of things. And so the visual technology can unlock all kinds of opportunities.
Developments in agritech are gathering pace, and farmers are already reaping the benefits. But with mounting pressures on food production, what other innovations are needed? Join me after the break when I'll be asking an expert in agritech about the cutting-edge developments in the industry. Modern farming is more and more reliant on digital technology to keep up with global demand. Disruptors and adapters alike are staking their claim in the farms of the future, and in the process, pushing forward the frontiers of new technology. Harper Adams University in Shropshire, UK is a world leader in agricultural technology and digital research. Part think tank, part farm, part laboratory, it's a center of excellence in the sector. One of its recent flagship projects is a hands-free hectare, a field of barley planted, tended, and harvested entirely by unmanned machinery. Simon Blackmore is professor of robotic agriculture at Harper Adams University, a member of the American Society of Agricultural and Biological Engineers, and a fellow of the Institution of Agricultural Engineers. His research has been breaking new ground in digital farming. Simon believes we need to entirely rethink our approach to farming in the 21st century.
There's a lot of pressures on crop production around the world at the moment. Obviously, we've got an increasing population that we need to feed, but there's also environmental pressures. And the current system that we've got for crop production uses a lot more energy than we need, and that energy comes in all different forms, from fertilizer, pesticide, tractors, diesel, and so on. To be able to meet society's requirements for these things, we need a new production system, and that new production system needs to have a new set of tools to allow us to do what we want the farmers to do. The opportunity that I see is to come up with a complete new mechanization system that moves away from an industrial type model, which is where we are at the moment, which is like a big production line doing the same thing everywhere, trying to increase the yields the whole time, into a much more flexible, dare I say, manufacturing system, like industry has done, but the farmers don't currently have the tools to do it. Our industry has moved over to flexible manufacturing. I think farmers should move over to flexible manufacturing, but we need the small smart machines to be able to do that.
One of Harper Adams' latest experiments in new smart machinery is Project Norman, a remotely controlled tractor designed for precision crop spraying.
This type of machine is what I think to be about the right size for agricultural robots. When we get to the tractor, big tractors, they are too heavy, they sink into the ground, If we make them much smaller, we have a problem with what's called the energy density problem. How much power can you get into a battery or a small engine? But this is about the right size to deal with agricultural conditions. When a normal tractor would sink up to its axles, this machine can go out and not do any damage to the soil, to be able to carry out the operations and not to compact the soil in any way.
Agriculture is an ancient industry and the backbone of our society. But if it's to withstand the pressures of the 21st century, then investment in digital technology is key. In recent years, capital has started flowing to the sector. But where is the river of investment going?
There is a lot of interest from the commercial sector now and the investment and governments around the world to make use of these technologies. The interesting thing really is that it's very disruptive, and a lot of the big machinery manufacturers are not investing in this area because it's too disruptive to their very linear business model that they've had for the last 50, 60 years. So the opportunity is really coming through startup companies. So we're working with a number of startup companies now who have no legacy in terms of what has gone on before, but are only interested in coming up with the right machines to meet today's requirements. So the stage really is where we've got a lot of, in some respects, crazy ideas, new ways of thinking. We're not totally sure which ones are going to pan out, which ones are going to be the most successful, but we're evaluating those ones, and we're seeing a lot more private investment coming into this area now to bridge the gap.
Eric Lemaire is the Food and Beverage Solution Marketing Director at Schneider Electric. Schneider are one of the more established players who are partnering with other businesses to explore the potential of digital farming.
I think the main work that is done at the present time in agri-tech is developing new capabilities to get information about the field, about the culture, and about the environment of the field. Smart farming is now something which is really efficient, and we can control the different equipment in the field based on the productivity, the yield of each part of the parcels. I see new opportunities with the usage, for example, of artificial intelligence. We are working with B Digital, a small company in Italy. They have applied the artificial intelligence on the agricultural data. So they use drones with high-resolution camera in order to have a map of the fields. And with artificial intelligence, they are able to detect the presence of bugs in the field, and from this the farmer can have manual removal of the bugs or a local treatment of the parcel which is contaminated.
Heavy investment in automation, robotics, and new sources of data are all helping to make farms more productive and less harmful to the environment than ever before. But is it enough for farming to meet the needs of our growing population? Join me after the break when I'll be finding out what new innovations are in store.
Agriculture is in the throes of a digital revolution, helping millions of the world's farmers reduce their environmental impact, improve efficiency, and drive up yields. But this revolution is only just beginning. So, what does the future hold?
When you visualize the farm of the future, what are some of the things you see? How is it different?
Well, for one, it's optimizing air and light. How do we make the plants as happy as they can be, basically? And they're going to give you the best result possible, but also make it accessible for people to harvest. Big, juicy fruit that's easily accessible. It's not hidden under the leaves. We want to be able to harvest, every berry and not leave anything behind, which in today's environment, that's not possible. There's probably about 30% waste in the system today. That's not all happening on farm. That's also within the supply chain. But basically, it's maximizing air and light, harvesting 100% of the berries, and really setting up the plants to be as happy as possible so that they produce the best crop.
But how does that change? What needs to be done for that to happen?
For example, on watering, let's just take that for example. Well, natural resources are obviously scarce and oftentimes finite. One of the exciting things that more precise farming practices and innovation unlocks is the better stewardship of water. And so we're seeing that in some of these advanced production techniques that we're implementing, that we're using up to half the water that we have otherwise, because we're giving little small shots of water exactly when the plants need it. We actually have scales in the field in the container production, in the tabletop production that you see here. We'll have scales in the field that are weighing the plants, and they can tell how much water or evapotranspiration is happening, how much water needs to be put back to the plant, and then that automatically triggers the irrigation. And so we might have 30 to 40 irrigations in one day, but it's only very, very small amounts and exactly what the plant needs.
For Professor Simon Blackmore of Harper Adams University, the future lies in our mastery of new, smart machinery.
As an agriculture engineer, I'm looking at agriculture from the machinery point of view, and I believe with the opportunities that we got in this new technology, we're going to get a new revolution in agriculture and crop production that is going to take advantage of these technologies. We will need new skills to do it. We'll have to have better understanding of the technologies. I still think it's going to be people making decisions, but it will certainly be supported by information-intensive data, by artificial intelligence, by decision support systems, but effectively it comes down to people in the end. But we will have a new set of tools that farmers have never had before to allow those decisions to be implemented in the field. There's still a person in control of it, in charge of it. Out behind me I could have a tractor that is then running, but I am in control of it because I've got a smartphone now, and there is a heartbeat going backwards and forwards between my smartphone and the tractor. But it may not be sitting on the tractor anymore, but can be within close proximity to the tractor.
For Mike Stern of Climate Corp, it's the gathering and interpreting of data on farms that could bring the biggest change.
The farm of the future, I think, could be very, very different than the farm of today. So there's no doubt that there will be more automation on the farm. There will be many, many more sensors measuring all sorts of different elements of how to manage a crop on a farm. There'll be integrated solutions where all sorts of different inputs will be brought together in an operating plan to optimize productivity around a field. We think there's tremendous opportunity to bring value to growers with these digital tools. So we're investing heavily in fundamental science here. I have no doubt that these technologies are fundamentally going to change the way that we use our natural resources to produce food. And even today, I am sure we can't even articulate where these technologies will end up 10 years from now.
What would you say to the farmer who hears this and then is concerned that there will be no more room in the farm of the future for the human worker?
I think the local knowledge and then the historic knowledge that farmers have around their field is always going to be important. Again, these are very, very complicated problems. And even today, we see as we're rolling out our digital tools, our farmer customers are typically working with their trusted advisor with this information, whether that be an ag retailer or a seed seller, an agronomist, a consultant on their farm. So I think that local knowledge and the passion that the farmer has about their land and their field is always going to be an important component in the development of new technology, including these digital tools.
For centuries, agriculture has been the dependable friend of progress, supplying our growing population with food and drink. But as environmental and economic pressures on farming mount, the time is ripe for progress to give something back. Global investment in agritech is having a massive impact on the sector. Automation and data-driven farming are helping food producers increase their yields and efficiencies. Farming methods as we know them are fundamentally changing, promising a healthier, more sustainable future for us all.
IoT, powering the digital economy. Brought to you by Schneider Electric.